In the previous session entitled Projections of Point, the procedure to obtain the orthographic projections of a point is very well explained. In that session, different positions of a point were considered, namely the first quadrant, second quadrant, third quadrant, and fourth quadrant. Now, in this particular session, we will go through the projections of point, and mainly this session is planned for the few problems related to projections of point. Before we start the problems, as discussed in the previous session entitled as a projections of point, there are three main points which needs to be remembered to obtain the projections of point. So first one is the projection of an object is on VP is the front view. Projections of an object on HP is the top view. This we have to remember. The first point is related to the projections of an object. Second point is related to dimension, and that is dimensions given with respect to HP is visible in front view, and dimension given with respect to VP is visible in top view. Okay. So first point is related to projection of an object, and the second point is related to the dimensions of an object with respect to HP and VP. The third point is related to projections, mainly the front view and top view. And the third point is that for a point, any single point, its projections, front view and top view, are on same vertical projector. These 3 points are important to solve the problems related to the projections of point. Now, starting with the problem, the first problem is that a point P is on HP and 30 mm in front of VP. This is the problem statement, and you have to draw its projections. So, this problem is demonstrated like this. Here you can see that point P is on HP. This yellow plane is the HP. This red plane is the VP, and position of this point P from VP is 30 mm. Now considering the second point that is related to the dimension, here point P is on HP. It means its distance from HP is 0. Okay? Because the point is on HP. So we know this point. Dimensions given with respect to HP is visible in front view. So here front view of a point P is at 0 mm from XY line. Means front view of point P, that is P dash, is on XY line. So here you can see that when you are viewing the point P from this front direction, you will get P dash on XY line. Similarly, dimension given with respect to VP is visible in top view. So here dimension of point P is given with respect to VP, that is 30 mm in front of VP. So top view of point P, that is small p, is 30 mm from XY line. So here P dash and P are the projections of object, that is nothing but a point capital P. So this is the demonstration of the problem. Now we want to draw its projection. So we know that VP, that is red plane, will remain as it is, and we will rotate HP in clockwise direction by 90 degree. So ultimately we get both the projections on same plane. So now to draw this projection, the final answer, first step is to draw a XY line, that is nothing but the reference line. Then draw a vertical projector. Here, this second point, that is draw a vertical projector, is related to the point 3. What is point 3? That for a point, its projections, front view and top view, are on same vertical projector. So because of that reason, to draw the projections of point P, that is P dash and P, we have considered here a vertical projector. Okay? Now mark P dash on XY line on a vertical projector, because here P is on HP, so P dash is on XY line. And mark top view, that is small p, is 30 mm below XY line on same vertical projector. Yeah. So this one is the final answer of the problem. So now we will see how the answer is ultimately drawn. So this one is the problem statement and you have to draw projections of point P. Then the answer is draw XY line, draw vertical projector as point P is on HP. That means P dash on XY line and P is 30 mm in front of VP. When we rotate HP by 90 degree in clockwise direction, so the top view of point P is 30 mm below XY line. So this one is the final answer of the given problem. That is, if point P is on HP and 30 mm in front of VP. Now we will see the next problem. So second problem is, if point P is on VP and 50 mm above HP. So graphically it is demonstrated like this. Point P is on VP and 50 mm above HP. So again we know that point P is on VP, so its distance from VP is 0. Now distance from VP is visible in top view, that means top view of point P, that is small p, is on XY line. Similarly, dimensions with respect to HP is visible in front view. So front view of point P, that is nothing but the P dash, is 50 mm above XY line. So this one is the demonstration of the given problem, that is point P is on VP and 50 mm above HP. Now rotating the HP by 90 degree, we will get the projections of point P like this, right? Where top view of point P, that is P on XY, and front view of point P, that is P dash, is 50 mm above XY line. So draw XY line, draw vertical projector on which both the projections will be considered, P dash and P. Now we know that top view is on XY line and front view, that is P dash, is 50 mm above XY line. So final answer we obtain is this. For the given problem that a point P is on VP and 50 mm above HP, the final answer is this one. So the answer is draw XY line, draw vertical projector. Here point P is 50 mm above HP, that means front view P dash is 50 mm above XY line, and P is on VP, that means top view of point P, that is P on XY line, right? So this one is the answer. The third problem is that if point A is 30 mm above HP and 30 mm behind VP. Here position of point A is above HP and behind VP. That means point A is in second quadrant and point A is at equal distance from HP and VP. We also know that when object is in second quadrant, its both projections, that is front view and top view, are above XY line. So first of all, we will consider projection of a point A on VP, that is nothing but the front view. So the dimension given with respect to HP is visible in front view. So top front view of point A, that is A dash, is 30 mm above XY line. Similarly, dimension given with respect to VP is visible in top view. So top view of point A, which is the projection of an object on HP, okay, that is A, is 30 mm from XY line. Okay. So here front view is 30 mm above XY line, as well as top view A is 30 mm from XY line. Now when we consider the projection on same plane, that means we are keeping VP as it is and rotating HP by 90 degree in clockwise direction. The answer will be like this. Here point A is at same distance from HP and VP, so its projections A and A dash, front view and top view, are at same distance, that is 30 mm from XY line. And here point A is in second quadrant, so both the projections are above XY line. So draw XY line, then draw a vertical projector on which both the projections will be considered. We know that A dash and A, that is front view and top view, are at 30 mm above XY line. So first we will draw the front view, that is A dash 30 mm above XY line, and same point will be the top view of point A. So final answer is that draw XY line, then draw vertical projector, and on this vertical projector first mark A dash, that is front view of point A, 30 mm above XY line, and same point will be the top view of point A. Next, we will see the fourth problem, that is draw projections of following points on same reference line. Keep distance between projectors equal to 12 mm. Okay. Here there will be number of points. Okay, and you have to draw the projections of all the points on same reference line. That means the XY line will remain as it is, and you have to draw the projections of different points keeping the distance between their vertical projector equal to 12 mm. So the first point is point M is 25 mm behind VP and 30 mm below HP. Here we know that point is behind VP and below HP. Okay, so the point M is in third quadrant. Okay, when object is in third quadrant, its position is behind VP and below HP. So when object is in third quadrant, we know that top view will be above XY line and front view will be below XY line. So for point M, top view will be above XY line and front view will be below XY line. We know that dimension with respect to HP is visible in front view. That means front view of point M, that is M dash, is 30 mm below XY line. Also, the dimension with respect to VP is given, that is 25 mm. So top view of point M, that is small m, will be 25 mm above XY line. So when you draw the projections of point M, it will be like this. Top view of point M, 25 mm above XY line, and front view of point M, that is M dash, is 30 mm below XY line. Here front view is below XY line and top view is above XY line, as the point M is in third quadrant. Next point is point I. Point I is 25 mm in front of VP and 25 mm below HP. Here, position of point I is in front of VP and below HP. That means point I is in fourth quadrant. Okay? And we know that when object is in fourth quadrant, its both projections, front view and top view, are below XY line. Right? Here, position of point I is at equal distance from VP as well as from HP. So, projections of point I, that is I dash front view, and I, that is top view, are 25 mm below XY line. Right? So, final answer is this: I dash and I both are below XY line. Okay, as point I is in fourth quadrant. Also, as per given data, the projections of point I are considered on vertical projector, which is 12 mm away from the vertical projector of point M. Next problem, that is point T is 25 mm in front of VP and 25 mm above HP. So here position of point T is in front of VP and above HP. That means point T is in first quadrant. Okay? And we know that when object is in first quadrant, its front view will be above XY line and top view will be below XY line. So here also position of point T is at same distance or at equal distance from HP and VP. So front view of point T, that is T dash, will be 25 mm above XY line, and top view of point T, that is small t, is 25 mm below XY line, as point T is in first quadrant. So the projections of point T is like this: T dash is 25 mm above XY line, and T, that is top view, 25 mm below XY line. So next point is point E, which is on VP and 35 mm below HP. We know that point E is on VP, that means its projection, that is top view, is on XY line. Now before solving the projections of point E, let's demonstrate the problem. Now point E is represented like this. Here you can see that HP and VP are considered. Fourth quadrant is represented. Here, as per given data, point E is on VP. So point E is on VP and its distance from HP, that is from XY line, this distance is given as 35 mm. Okay, so this distance is 35 mm. Okay, so for the front view, we will view the object from this side, and for the top view, we will view the point E from the top. So on XY line, we will get top view of point E, that is small e, and front view of point E, that is E dash, is at the same point, that is the main object point E. So we will get the answer for the point E is like this: top view of point E is on XY and front view, that is E dash, 35 mm below XY. Next point is point S. that is on HP and 30 mm behind VP. Let's demonstrate this problem, means position of point S. So to demonstrate this, consider HP and VP. To demonstrate the point S, here second quadrant is considered as the point S is on HP and 30 mm behind VP. So let's consider the position of point S is on HP, and this point S is 30 mm from VP. Okay. Is 30 mm behind VP. Okay. So the position of point S is 30 mm from or behind VP. Now we know that the viewing direction for the front view is this one. So we will get the front view of point S is on XY. So this point will be the front view of point S, that is S dash. Also the viewing direction for top view is this one. So the top view of point S will be the same point. Same point means point S. So this will be the top view of point S. Now we know that VP will remain as it is and HP will be rotated 90° in clockwise direction. So top view of point S will move in this direction, and that will be above XY, that is 30 mm above XY, top view of point S. Now solving the problem as discussed, we will get the projection of point S like this, that is S dash on XY, and top view of point S is 30 mm above XY. Next point is point H. Now point H is on VP and on HP. This means point H is on XY line. So its projection H and H dash are also on XY line. Okay. So this one is the complete solution. So this one is the complete solution of the problem 4, where projections of all the 6 points M, I, T, E, S, H are considered on same reference line, XY line, and the distance between their vertical projectors is constant or common, that is 12 mm.